Any question on that? No question. Alright, so then we are going to start our topics today. I have talked about actually that vector components or the coordinate system, actually how we are going to represent vector in different coordinate system. We represent in Cartesian coordinate system as well as polar coordinate system, plane polar coordinate system. In that way, actually, we can extend our idea for other coordinate system, for example, cylindrical and also spherical coordinate system. Anyway, so now today we are going to talk about that multiplication of the vector. So before I start the talk about the multiplication of the vector, I want to do a problem from which is actually the addition of the two vector. Say I have a coordinate system like that. And can you see my screen, right?
Yes, sir, we can see it.
Yes, sir.
clearly.
Yes, sir.
Alright, that's right. So say this is a axis I'm choosing over here. I have a vector, say, which is towards that. One vector is that direction, and another vector, say, in that direction. If I label that, say this is my positive x, this is my positive y, this is my negative x, and say the length of this vector, say I represent that vector actually by vector a, and this is the vector b, and this b vector create an angle 45 degree with that negative x-axis. And say for example the magnitude of a is 100 meter, which is the magnitude of that vector, and the vector b has a magnitude is 200 meter. Now I want to find out the resultant of this vector a plus b. What would be that vector? I want to find out the magnitude and the direction as well as. Now without doing that calculation, can anyone predict that what would be the resultant direction of this vector? Which direction it would be? Can anyone say me that one?
Just second coordinate.
Second coordinate. All right. I should say that's a very good guess. Is there any more guess?
Sir, along the direction of y-axis.
Along the direction of y-axis. That's good. All right. So look at this. I'm not expecting that you would be precisely say that one, but at least if you can make a guess, that would be very helpful for you. You will understand. So that look at this. I try to do that, and I'll do that mathematically. But before that, I just going to make a guess. What could be the resultant direction? To find out the resultant direction, basically I have to use that vector triangle law, right? The only law still we know, which is a very useful, and I can say that it's a powerful law to find out that direction of this vector. If I shift the origin of that vector p from here to here, then over here they will be basically head to tail connection, then I can use my vector triangle law. If I place in that way, I'll find out this is basically in the resultant vector, which is basically in the second quadrant, right?
Yes, sir.
Let's see that. We'll find what we find out for mathematically. To find out that mathematically, basically I have to express that vector in term of unit vector. So this is vector A. I can write is a 100 I hat, right? I just express that in term of unit vector I and j. Now what about the b? If I write down the b, b would be basically minus b cos 45 I hat, right, plus b sin 45 j hat. Can I write
Yes,
this
sir.
equation?
Yes, sir, this is correct.
Is there anyone have a confusion with that equation b? That is important over here. Unless you cannot express in vector in right way, your calculation will be the wrong. You have to understand why I am writing this b in that form.
Sir, it would be
So can you
helpful if you explain.
explain it a bit?
Definitely, I love to do that, but why I have to tell that? If you have the, you have to say that one. I said you have that right. If you don't understand, definitely you will ask the question. Don't think about who are someone going to be the laughing regarding your question. Please, guys, don't think about in that way. Otherwise, I cannot help you. All right, that's good.
Yes, sir.
Because once you ask that question, some other guys will be also helpful. I know that each and every one of you, except there would be some exceptional, they have the question in mind why it is that form, but they are not asking, which is very bad habit, I would say. I'm sorry to say that, but that's true. You are over here to learning, and I also come over here to learn something from you. Both sides will be benefited. So please, guys, ask the question if you do not understand. If I write then 2 plus 3 equal to 5, if you don't understand that thing also, you can ask that question.
Sure, sir. We will ask.
Alright, look at this. This one I just express the component of that vector actually. If you take the component of b along the direction of that direction, then you will find out this one, which is actually that b cos theta, right? Theta is 45. I should write theta. Alright, I'm going to write in terms of 45, then I think it would be helpful for you. It's going to be that b cos 45, that length. Will it be? Am I right?
Yes, sir.
Yes, sir.
And
Yes, sir.
this length, this one would be b sine 45. It's a component, right? Component of vector b
Yes, sir.
along the x direction, along the y direction. It would be over here, but I shift right down over here. There is a reason. Now, if I multiply that b cos 45 by negative I hat vector, I will find out that one. If I multiply b sine 45 with j hat vector, I will find out that one. Now look at this. Again comes to play the role of vector triangle law. Very beautiful law or very powerful law. Look at this. They are again head to tail connection over here. These two vectors. Definitely, then I can write that vector plus that vector would be the vector b. I write in that way, b equal to minus b cos 45 I hat plus b sine 45 j hat. That's why I write down the b in that form.
For it.
Is it all right?
Yes, sir.
Yes,
It's
sir.
all right.
That's great. Now I'm going to add these two, one a plus b, and now I can add. So one more line I have to write. So b, I know the magnitude of the b, which is 200. If you multiply with that cos 45, then I will find out minus 145 I hat plus 41 j hat. So this will be the vector b. Now if I add with that vector a, I can add with the I component, right? Then I will find out minus, I do in one line actually. So because 141 minus 141 plus 100, definitely it is going to be negative 41 I hat plus 141 j hat, right. So this is basically the resultant vector. Now I can write down the magnitude, and in definitely that resultant vector must be going to be in the second quadrant. So because your x component is negative and y component is positive, then resultant must be in between towards that, but it will be closest to the basically the y axis, because y axis has a greater magnitude, right. Now you can find out also, look at this, if I find out that magnitude of these two vector a plus b, which would be minus 41 square plus 144 square, right. So if I write minus 41 square plus 141 square, so that will give you, if you do that, it would be closely 147 meters. So that is the magnitude. Now if you do that angle, which is that formula, if you use tan inverse y by x, if you use that formula, what would be that? So tan inverse what is that, y, which is 141 divided by 41 minus 41, basically minus 41. So if you do that calculation, you will find out the angle would be basically negative 74 degree, right. Now what is this negative 74 is indicating over here? Remember, when you are going to use that formula, I said you basically, if you use that formula y by x, it will always give you from nearest x to y direction, angle direction would be. If you use that formula tan inverse y by x, it always give you the angle from nearest x axis to y axis. Now this is my x component, which is towards the negative x direction, and this is my y component, and I know the resultant vector is in between these two. Then my angle would be nearest x to y, means this would be my angle, which is actually the 74 degree. Now why this minus sign? Because it's moving its direction right now in the clockwise direction. I say the any angle, if it is the clockwise direction, that would be the negative. Any angle it is counterclockwise direction, that would be positive. We'll also follow that convention over here, then we can find out the angle precisely. Now then and now the question is come over here, sometime if you only say the minus 74, then I can say it would be in also in the fourth quadrant. If it is created from that x to y minus 74, that also the correct. But for this condition, it is not going to be the correct over here. So then I have to say minus 74 from negative x axis, then I can precisely measure it should be in the second quadrant. If you only say the minus 74, I could be assume it would be in the second quadrant, or it could be in the fourth quadrant. To overcome this confusion, you have to write in that way minus 74 from negative x axis, or you can write, which is the general convention, which we will count on the angle from positive x axis counterclockwise. Then I should write it would be 106 degree. That would be the precise angle over here. For this one, actually I did this problem to talk about this case. So do you remember, this point is very important over here, to precisely measure the angle, because unless you cannot find out that resultant direction of the direction of a vector, then it would be difficult for you in the next chapter when I am going to talk about the motion of a particle. In that case, you cannot predict what would be the resultant direction of that particle, because I am going to use that idea in over there. So that's why I am doing this thing over here. Say for example, I have a vector which is, say that A, I represent, say arbitrary vector is a 2i plus 2j. What would be its angle? What would be
So
same?
that would be 45 degree.
That would be 45 degree. That's very good. If I say the vector is minus 2y and minus 2j, what would be that angle?
That would be 45 degree also, but in negative direction of y-axis.
Negative direction of the y-axis. 45 degree negative towards the negative direction of the 40 y
I mean,
direction.
if we calculate that from the negative direction of y-axis to the resultant, then it will be 45 degree.
So that's when you were saying that, let me check. So you were saying that this is your negative y direction, right? So angle would be in
Yes,
that
sir.
direction.
Yes, sir.
All right. What would be that angle in that case? 45 degree.
That would be 45 degree. Yes, sir.
Then you should say that from negative y-axis minus 45 degree. Because
Mm,
in
from
negative
negative y-axis, yes, sir.
it could be also the 45 degree over here,
Yes, sir. From
right?
negative direction, that will be minus 45 degree.
Exactly. You have to precisely mention that one, because when you use
Okay,
that
sir.
formula, tan inverse y by x, which is minus 2 divided by minus 2, is ratio is going to be give you tan inverse minus 1. Sorry. Right. Because
Yes,
your
sir.
calculator is going to give you basically that 1 over here. He's right. That device is right. Also sometimes I say there is basically the stupid device, so it's not active, right? So
Yes,
definitely
sir.
it's right, because 2 minus 2 over 2 ratio is the 1, is going to give you the 45 degree. If you say the angle is 45, then I will assume it is in the first quadrant. But if you
Yes,
say
sir. But
that
we always have to look at the
component, you always look
components.
at the
Yes, sir.
component. If you look at the component, then you can guess that why would be that angle, because this vector x component is negative, y component is negative, then definitely the resultant would be in between that two. That would be the position. Then this 45 basically from nearest x to y, this one nearest x to y again, right?
Yes, sir.
And it is counterclockwise, so that's why it is positive 45 over here. That stupid device is absolutely right over here, but it is measuring from negative x-axis. Then I have to do one thing. I have to say from negative x-axis plus 45, or I can say 180 plus 45, which is 225.
Yes, sir. So for understanding an angle, we can just look at the components and determine which quadrant the resultant is in. And then
Yes.
we can just determine the angle.
Yeah, it will be very helpful in that case. You can precisely find out the location of that particle or the
Yes, sir.
resultant direction of the vector. The same thing we can say, if the vector is right now, say that 2i plus 2j, in that case what would be that?
That would be the second quadrant, sir.
Second quadrant?
The resultant.
Mm-hmm.
Minus 2y and then 2j.
Yeah.
And then the angle will be 45 degree.
Yeah, angle will be negative 45
Yes, sir. Negative 45.
from negative x-axis, right? Or
Yes, sir.
we can write 135 degree.
135 degree.
Or the last one, if I think about, say that if a is, if I write the 2i hat minus 2j hat, that is also going to be that minus 45 degree right now, which is it is right now.
Negative direction of y-axis.
No, negative direction.
Sorry.
It's a negative
Sorry.
from negative x direction.
X
Because
direction, sorry.
right
Yes.
now this is your resultant vector, and this is actually minus 45. It's right. It's a clockwise direction right now. Right?
Yes, sir.
This direction is
Understand.
clockwise. That's why I can say the minus 45 is absolutely right. Or you can write down 315 degree. This angle, 315 degree. Right?
Got it, sir.
Yeah, that's
Yes,
how
sir.
actually you have to find out the angle of a vector, which is very useful, and you have to do in that way. If you make a mistake to find out the resultant direction, then it will be difficult for you to find out the or predict the trajectory of a particle for 1D and the 2D motion.
The answer will be wrong most of the times.
Yeah,
Sir.
exactly. All right, let's talk about that multiplication of vectors. There are two way we can do the multiplication of vectors. Say I have a vector, I am going to represent in Cartesian coordinate system, which is ax I hat plus ay j hat plus az k hat, and vector b is bx I hat plus by j hat plus bz k hat. These are the two vector actually in Cartesian coordinate system. Now I can find out that dot product, there are two product actually, right? We say one is the dot product, one is the cross product. So dot product, or sometimes we say that scalar product, or sometimes also we say that this is actually the inner product. Inner product, we use that keyword in the case of quantum mechanics. Inner product, this one could be done in the two way. One is, say, if I write A cross B, actually, sorry, I'm extremely sorry, it's a dot product. This would be A dot B, that would be ax I hat plus ay j hat plus az k hat dot bx I hat plus by j hat plus bz k hat. Now what I'm going to do, I'm going to multiply of this ax I hat with the rest of the quantity of the vector b, right? I'm not going to do every component over here, I'll show you one, then you can find out the other component. So what would be the case? It would be ax bx I dot I plus ax by I dot j plus ax bz I dot k, and rest of them will be so on, right? You can multiply ay with the rest of the b component, you can multiply az with the rest of the b vector component. Now I know that from the properties of the unit vector, the similar identity will be survived, but the dissimilar identity will be vanished. Then in that case, I dot I basically the 1, but I dot j and j dot I dot k would be basically that 0. It will cancel out this component. Then I can find out basically it would be a dot b would be ax bx plus ay by plus az bz, right? So this is would be actually the dot product of this vector. You can find out in a that way. This is one way. Another way we can find out, which is a dot b would be ab cosine theta, right? This one also could be the proof, but I don't want to do that, it will take some time. This one is also available in the online. If you want to find out, you can search this thing, how this equation is right in that way. And basically this one, actually if you draw, so this is a vector a, or say this is the vector b, then the angle is between that vector, actually the theta, then we can write on this one a dot b, actually the ab cosine theta. And this formula is again very useful and the powerful formula to find out the angle between that two vector. Always try to use this one to find out the angle between the two vectors, it will give you always the accurate angle or exact angle between the two vectors. There is one more way you can say that there is also cross product formula, right? Whether there is a vector 2D or 3D, but cross product formula actually sometimes will not give you the exact answer if you cannot find out the resultant direction precisely or resultant vector. So sometimes if you cannot set up that two vector in a way, then it sometimes give you the wrong answer actually. So that's why it is safe to use this dot product to find out the angle between the two vectors, and it's very handy. Now look at this. This one I can write, say, if what is this over here, b cos theta. Actually b cos theta actually the component of vector b along the direction of vector a, right? We talk about this thing when you're talking about this one, b cosine theta. Or I can write down this one in a form which would be a cos theta into the b is the same thing. Now a cos theta actually that component of vector a, which is a cos theta, component of vector a along the direction of vector b. We will find out that one in a form. Now since this dot product is a scalar quantity, it has, we can say that value of this could be greater than 0, it could be equal to the 0, and it could be also the less than 0. It will be greater than 0 if theta is greater than 0 or less than 90. It will be equal to the 0 if theta is 90. It will be less than 0 or the negative in the case that theta is greater than 90 or less than 3 pi by 2. That's mean 270. In that region you can find out where this is going to be the positive, negative, or equal to the 0 of this case. And there are also some properties we can say that basically dot product is symmetric. So that's mean if I write a dot b, that would be also that b dot a going to be the same. That's why it's called the symmetric distribution, because if you multiply 3 with 5 or 5 with 3, it doesn't make any difference. It's the same result, which is the 15, right? So that's why you say that the dot product is symmetric. We can write in that way. There is also, it's called the distributive, which is, we can write, say, a dot b plus c. We can write a dot b plus a dot c, or I can write this one is b dot a plus c dot into a, because it's a symmetric distribution. We can write one more case, actually say that m into a, I have m is a scalar quantity over here, I multiply with the vector a, and another scalar quantity, say the n, I multiply with the vector b, then I take the dot product of these two one. If I take that, I can write down that result m into n into a dot b, it will be the same. Now there is one more case actually, I'll talk about this thing. In the case of triple product, I will use that thing. Alright, let's consider a case like that. Say so I have a cube, So this is a cube. Say this is actually x-axis, this is actually the y-axis, and say this is the z-axis. Now I have to diagonal vector, which is actually in the this diagonal vector into the yz plane and this diagonal into the xz plane. Say I level, this is that vector A and this is the vector B, right? I want to find out the angle between these two diagonal vectors. What would be that angle? Can you make a guess?
Right angle.
Right angle. All right. Fine. Yes. Is there any more answer, or all of you agree with him? Alright, so if I want to find out that angle, definitely I'm going to use that formula over here, which is A dot B actually AB cos theta.
Yes, sir.
Right? This is the formula I say. Then I have to find out that vector A and B. This is actually the angle, the theta. So if I want to find out that vector A and B, say I can write this coordinate of that point would be basically 1 0 1. I choose the one side length of this cube, say the 1. So A's length actually the 1, I can say. Then the coordinate of this point would be 1 0 1, because this is my x unit. I am moving over here. I do not move to that y-axis at all. Then I move to the 1 unit towards that z-axis to reach that point. Then I can say the coordinate of that point would be 1 0 1, right? By the same analogy, I can say the point of coordinate of this point is going to be 0 1 1. Am I right?
Yes, sir.
Yes, sir.
Alright, then I can express that vector A in that case is a 1 I hat plus 0 j hat plus 1 k hat, because these are the component I can consider 1 0 1, right? It's a coordinate. It will be,
Yes, sir.
then I can say this vector A would be basically I hat plus k hat. This is the vector A. Definitely this is one vector and this is another vector. Using the again the vector triangle law, I can say that resultant vector would be the A. Then I can also find out the vector B using the same analogy. Vector B would be basically j hat plus k hat, because it's a 0 1 1, right? Fine, I find out these two vectors. Now I can find out the magnitude of vector A. Magnitude of vector A would be basically 1 square plus 1 square, which, because magnitude of this I j k basically the for 1 in Cartesian coordinate system we define in that way. Then I can say this magnitude would be square root 2. The same analogy over here, it would be square root 2 also. Then I'm going to find out this A dot B over here, which would be I plus k into j plus k. Then I'll find out this I dot j is 0, I dot j plus I dot k is 0, for I multiply with this I with the rest of the quantity of vector B. Now with the k dot j is 0 plus k dot k actually the 1. Am I right?
Yes, sir.
Yes, sir.
Fine. Now plug in into this case because this is actually your a b cos theta. Then I can write a dot b basically the 1. Magnitude of a is root 2. This is also root 2 into cos theta, right? Root 2 into root 2, I'll find out only the 2. Then I can say that the cos theta is basically the half, right? Then it would be basically that cos 60 degree, because cos 60 degree is basically the half. Then that's why the angle between these two diagonal is 60 degree, although the plane is 90 degree to each other, but the angle between these two vector is 90 degree, which is the shortest angle, you can say in that way. So that's why actually we can use this formula to find out the vector, find out that with any case actually we can find out. Now even though say I can, if I ask you what is that vector create the angle with this z axis, what would be that?
So what was the question?
Question is, what is the angle the vector b is create with that z axis?
So it should be just b cos theta, I think.
No, that's not the angle.
So 45.
45. All right.
Yes, sir. 45 degree.
Yeah, you are absolutely right. It should be 45. Then say how I'm going to find out that one? I have only that vector b. Then how I'm going to find out that one? So probably you are, since you have the vector b, you will write down tan inverse y by x, which is mon by 1, right? Which is 1, actually the tan 45 will be 1. Right? This is the case actually. You can find out the another way actually. Say I don't want to use that formula. I know this formula could be useful for two-dimensional case. Say if the vector is three-dimensional case, what would be the case? Say I have a vector like that. Yeah, let's do that one. I can show it from there, but I need to show you another way. And say this is my x-axis, this is my y-axis, and this is my z-axis, and say this is the vector is a. Now I am to find out, say that what would be that angle which create with that z-axis. Say the vector is given, I want to use a precise value, then it would be easier for me to do that calculation. Only for the calculation I am going to say that vector a is written in a form which is vector a is written in a form which is, say that 11 I hat plus 5 j hat minus 7 k hat. Then I want to know what is the angle is created with the z-axis. I don't have any other information. I'm going to find out.
So 90 minus 10 theta 7 by 5.
90 minus tan theta 7 by 5. Why you say that one? Let me check. So you say that minus 7 by 5, right? Minus 7 by 5 into tan inverse which is minus 54, and we multiply with that plus 90. No, that's wrong. All right, so
we can use the direction cosine equation to find the angle.
Direction cosine, yeah, we can do that, but that's a process, it's a lengthy procedure actually. So why don't you guys basically the vector I drawn it over here is not actual vector, it would be different, because I'm sorry, I need to redraw that one according to this vector. I'm extremely sorry guys, because look at this, this coefficient of this vector is the 11i 5j minus 7k, right, which is mean that say I have to move the 11 unit towards x direction, 5 units towards that y direction, and minus 7 unit, which is I have to go in that direction towards the downward direction, right? Say for simplicity, only for this calculation I change that orientation of that vector, because I'm taking that vector, otherwise that draw would be inappropriate. So this is that one. I'm sorry, I have to raise this issue over here. Yes, if someone have a question, you can ask. I want to find out that angle. Only they give me that vector and I want to find out the angle it create with that positive y-axis. How I'm going to find out? Do you agree with me that from that diagram we can say that this vector actually at the below of this xy plane, right?
Yes, sir.
Yes, sir.
And it means that the angle would be greater than 90 degree, right? Can I make that prediction from here? Because
Sir, should we consider the axis z as a vector as well for here?
yeah, obviously.
So like, can we do that?
Well, of course, why not?
So like considering vector z as just k.
Yeah, I'm going to do that one, because I'm doing only for representing that of your idea, because I will use that formula. I say that a dot b is always applicable in every situation. I can do that. Now here is the situation, I have only one vector. For this one I need the two vector to find out the angle, but in this case I have the only one vector. Then what can I do? I know there is one more unit vector towards that direction, which is the k hat. Alright, so this is to be my vector a dot k hat. I can find out the magnitude of a. The magnitude of a would be probably 11 square. If the magnitude is basically 195, root over 195, you can do that. You can find out this thing. Then root over 195, I know the magnitude of vector k is the 1, and this is the angle, is the cos theta. I'm going to find out that one. And what would be a dot k or k dot a?
Minus 7.
Minus 7, because I dot k is 0, j dot k is 0, k dot k would be 1. I'll find out the minus 7. Then I can find out this cos theta would be minus 7 divided by root over 195. And if you do that, in this thing you will find out the theta would be 120 degree 0.08. That should be the angle which is greater than 90 degree. That should be the procedure actually to find out the angle. Now I can find out the any axis I want. If I want to find out with that x-axis, right, this angle. So with the x-axis I can find out, even with that y-axis, even with that negative z-axis, is any axis I want, I can find out the angle using that formula. So that's why I say that this formula is also a very powerful formula to find out the angle between the two vectors. Always try to use that formula, it will help you a lot.
Sir,
Yeah.
it will be helpful if you explain the formula again.
Which formula?
That means the how we are finding this direction.
Oh, I use that formula only. A dot B actually AB cosine theta. You know this formula, right?
Yes.
And I know this. To use that formula, I need the two vector. But in this case, the scenario I raise over here, I have the only one vector is the A,
One.
and another
Yes.
vector I know there is one other vector is in the Z direction. I need that one because I'm going to find out the angle with the Z axis. So that's why I use that another second vector as a k head over here. I know the magnitude of that vector also, which is the 1. That's why I write a dot k. Where's my cursor? I write a dot k. This is the dot product, and this is the magnitude of vector a, and this is the magnitude of vector k, and this is the cos theta. Then I do the simple algebra over here to find out that angle.
Okay. So, okay, sir. Okay.
All right. Is there any more question? Someone give me the message. Ikram Ahmed. Hello. Is there any of you have a question?
Sir, I don't think we have any more questions.
Oh, that's great. Then give your attendance. Write your only the ID. Write your ID only within the 2 minutes. Do it. Yes, Mahir. What's your issue?
Sir, regarding the example you just showed, uh, in the exam, if such questions come, like, do I have to use that dot product, or like I can use something else, like just trigonometry and other stuff to solve that?
Yeah, you can do that, but that will, I think, you will be, if you make a mistake, there will be a probability to your answer is going to be the wrong. Then it is always safer to use that formula a dot b equal to ab cosine theta to find out the angle between any vector, between two vector. It's very easy and it's very handy, I can say that. But if you do
Okay.
in another way, you can do that. If you make it correct, I don't have any issue. But if you make a mistake, definitely you are going to be lost some mark. But I don't want to that you will lose some marks from this simple idea or simple case actually, at least from the vector. Alright, the second one we can do that vector product, or sometimes you say that the cross product, or sometimes we say that outer product. We use this keyword in the case of basically, sorry, that will be O. In our quantum mechanics language, we use that is actually the inner product and outer product. We don't use that vector product and the dot product in that mechanics. Alright, so we can find out this cross product or the vector product also by the two method. First one actually the determinant method, which we write, say, in the same vector we can write, say, A cross B is equal to I j k which is ax, ay, az is the coefficient I'm writing of that vector, and this is actually that bx, by, and the vz. I just write down those two vectors initially I assume, which is, sorry, a equal to ax I hat plus ay z hat plus az k hat, and vector b actually bx I hat plus by z hat plus bz k hat. Right? So I just plug in this coefficient of these two vector a and b over here. Now you use a procedure actually, the determinant procedure actually. In that way you use a bar, then take the cross product and so on for the y-axis and also the z-axis. But as doing that thing, sometimes you guys make a mistake. To overcome that confusion, because mostly in the is become the issue, the plus minus issue for the j component or j hat component actually. But to overcome this thing, I carry this information in my head in that way. Look at this. I'll write this one would be ay bz minus az by into I hat plus az bx minus ax bz z hat plus ax by minus ay bx k hat. That should be the case actually, but sometimes some of you use the minus sign over here. Alright, that's also going to the work, but using that minus sign you make a mistake. If you use the minus sign over here, it would be basically ax bz minus az bx, which is the same thing. There is no difference. But how do we write down this equation? I use in that form, say that x, y, z, I write in a cyclic order. When I am using this coefficient of x, I take the other two coefficient y and z. I write down first vector ay into bz, which I am moving to the counterclockwise direction, minus az by. Right now I am moving to the clockwise direction, that's why it's a negative. When I write down the x component, coefficient of x, I will start ay bz minus az by. This is this quantity, first quantity. Now for when I am considering the y component, this one I will start from the z component, az bx minus ax bz, right? This one, this component. Now for when I am considering the z component, I will start from ax by minus ay bx. So there will be no confusion where would be the plus and where will be the minus. Look at this, I use the plus. When I move to the counterclockwise direction, I take the positive. When I move to the clockwise direction, I use the negative. That's how actually you can overcome this plus and minus sign or plus and minus sign issue over here. I use that information in my head in that way, because most of the time you guys is memorize, and when you're going to do that you make a mistake over here. If you write the minus sign, you shift this, and then which is unfair. It would be unfair to make a mistake this formula at this level, because you are learning this formula from your school life or O level, I should say. Then that's why if you make a mistake to write this formula in this level, it would be very unfair. So I don't want to you guys will do that the same problem. So you can use that technique if you think it will be helpful, I think, in that way. All right, so do you have any question?
Sir, so like every time a problem comes up, do we have to show the whole process, or we can just,
No, you
show the
don't have to show the
calculation?
process. You will have, you will just write down the formula directly. But I'm showing you, so because from my experience, where a student make a mistake, because when a student write down this wrong formula, it's very unfair at this level to write down this wrong formula, because they make that mistake because that they memorize this formula. But I don't want that my student will memorize this formula for this. Why you memorize this thing? It's basically that if you apply some technique, you can easily carry this information in your head. I'm showing you that technique actually. Alright, let's come to the another method actually, which is we can write A cross B would be A would be sine theta into eta hat, right? This is one more formula actually, where this eta must be that perpendicular on both A and B. It doesn't require that the AB would be perpendicular to each other. Say this is your vector B and this is your vector A, then theta is between these two vectors. In that case, this eta is the direction that would be perpendicular to direction both and B. This is will be actually the direction of eta hat. It could be upward or it could be to also the downward. In that case, it will be the minus eta hat. If you write A cross B, that would be towards the positive. I am writing the direction only. A cross B would be over here towards that positive eta hat, which is the upward direction. For that one, you have to use the right hand rule. For that rule, you have to put your index finger towards the first vector and your palm towards the second vector. If you do in that way, then if you rotate from all of your finger from first vector towards the second vector, then your thumb will give you the resultant direction of that product. So that's why if I place my index finger or the forefinger towards that direction, say, and this is my thumb would be over here, and if I rotate this finger from first vector to the second vector, then my thumb would be basically the upward. But if I do B cross A, in that case I will place my forefinger towards that direction and palm would be towards that vector A. Then I rotate from B to A, my thumb would be in that case is basically in the downward direction. So this is will be that minus eta hat. So that's why this A cross B not equal to that B cross A. You can write down equal. In that case you have to give a minus sign. A cross B would be the minus B cross A. That's why you say that the dot product is anti-symmetric. It's not symmetric like that dot product where you write A dot B equal to the B dot A. But for the cross product, which is anti-symmetric, if I want to write A cross B, I have to use a minus sign in front of that. So that's why I write A cross B equal to minus B cross A. Remember this point. And I say that this A or B is not perpendicular to each other. Sometimes it could be, but most of the time it's not. But this eta hat must be separately perpendicular on both A and B. It has to be. This eta hat is perpendicular on A and also that vector B separately. Alright, we can say this cross product actually has also some magnitude. That magnitude could be greater than 0, it could be equal to the 0, and it could be also less than 0, which is negative. It's positive when the theta is greater than 0 but less than pi, that's in 180 degree. It will be equal to the 0 when theta is basically n pi, where n actually start from 0, 1, 2, 3 and so on. And it will be less than 0 when theta is greater than pi and less than 2 pi. In that reason you will find out that magnitude of this cross product could be the negative. All right, so this cross product I already said then is a basically follow that is a anti-symmetric. I would say it's anti-symmetric is a cross B not equal to that B cross A. If you want to say, you have to basically give it the minus sign, and its distributivity is A cross B plus C equal to, I should write A cross B plus A cross C will be that, and this one is, I can write M into A into N into B, which is going to be M n A cross B with that form. These are the properties of that cross product. Now let's talk about is a physical significance of this cross product. Say I have two vector, say this is the vector A and this is the vector B, which is say the length of the two sides. Is over there, knocking me. One over here. All right. Say if I take that cross product of these two sides of this vector or the region, what it will give me? Do you have any idea? If I take, say I have this a place, it's like a rectangle shape area, a rectangle shape region, then I express one side by the vector A and the other side by the vector B. Now if I take that A cross B, what it will give me? What physical quantity I will find out it from here? Do you have any idea?
So area.
It's going to be area. That's great. And area is a vector, right? Remember this point. Area is a vector. It has some direction. Area is a vector. That's why when you learn that formula area in your school life, you always write down in that form, length cross breadth. You never find out length dot breadth. They don't use that dot product over here. They use that cross thing over there because it's a vector. Remember, area is a vector. And this A cross B, for this region, it will give you the area of the shaded region. And if you ask me what would be then in that case the direction of that vector, it would be perpendicular
Upwards
to that surface if I write down the A cross B. But if I take the B cross A, that would be in the downward direction. So that's why this is the physical significance of this cross product. A cross B will give you the area of that region, and this direction of the area would be always perpendicular to that surface, either upward or the downward. Fine. Now say why I'm saying this one, there is a reason. There is a term we use in the case of, it's called the triple product of the vector. What is that? Say I have three vector A, B and C. Say first if I take A dot B cross C, what it will give me? Is it a vector or it is a scalar?
it's a vector.
It's a vector. Is there any more answer? Is it will give me a vector, or at the end it will give me a scalar?
Sir, vector.
Vector. All right. Say, if this parenthesis I replace by a new vector, say the d, then I can write this one a dot b. Is it a vector or a scalar?
It's a scalar.
A scalar. So ultimately a dot b cross c will give me a scalar. It's a scalar product. Final quantity would be scalar product. Now think about it another way. So what is the physical significance of this one? What it will give me? Say you have that region, you express, this is say that vector b, and this is the vector c, and this is say that the vector a is towards upward direction. So what I will find out? Physical quantity, what will give me? I know this b cross c will give me that area, right? With respect to that area, if I multiply one more side, one more length, what will give me?
Volume.
It's a volume, right? Area into length, one more length will give me the volume. So that's why this, and volume is a scalar quantity, right? So then I can write down a dot b cross c is a volume, would be equal to b dot a cross c, or equal to c dot a cross b, is going to be the same product over here. Now,
sir, I do have a question.
Yeah, sure, go ahead.
So, sir, vector b times vector c will give me a scalar product, right?
Yeah.
So, sir, a scalar
Vector
product
b
times a vector should, sir, vector b times vector c.
Yeah.
That will give me a scalar product, right?
Vector time means what is, yeah, you saying it's a cross.
Sir, yeah.
No, it's a vector. B
Okay.
cross c is a vector.
Right. Yes, sir. Sorry, my bad.
All right. So fine. So then, if you is it okay for you the equation I write over here? I make a box over here. Do you convinced that this product, all product is going to be the same? A dot b cross c equal to b dot a cross c equal to c dot a cross b.
Yes, sir.
Why it is so?
Yes, sir.
Why it is so?
Because volume is a scalar quantity.
It's basically the volume of that box. Whatever the measure, you take one side length and the another side and multiply by that one, it will give you ultimately the volume. So if you measure from different side, the volume of this object is not going to change, it will remain same. Right? It will be remain same. Say for example, if I draw in a different way, different shape, say this is this one, and say this one. This is a box. If you take that area, this face, by that length, it will give you the volume of this object. If you take that area and multiply by that length, again is going to find out that same volume of this object, because the whatever the measurement you take over here, the volume of this object is not going to change unless you destroy the system or destroy the box. Am I right? Am I right?
Yes, sir.
That's why this product is all will be the remain same, because ultimately is giving me the volume, which is a physical quantity, is a scalar quantity over here. That's not going to change for a particular object. It will be remain same. So that's why I write down this equation is going to be the over same. But what if, say, if I write A cross B cross C, Is it a vector or a scalar? This triple product is a vector or a scalar?
Scalar.
Scalar?
Vector.
It's a vector. I didn't use any dot sign
It's a
over it.
vector product.
It's a vector product, definitely, because if you write A cross, if I say consider, I write down the B cross C is a new vector, say that D, that is again the cross product. It's a vector product. So that's why I can write, say that A cross B cross C equal to B cross A cross C is not going to be the equal. That will be the different. Or say not equal to C cross A cross B. Why it not be equal? Because of its direction will be the different direction. If you change the direction of a vector, definitely the vector is also going to be the change, right? The vector will be the change if you change the magnitude as well as if you change the direction, or if you only change the magnitude or only the direction. In both cases, the vector is going to change. So that's why these quantities are not equal. And to perform this operation, basically you can take step by step. For this one, you will first take that cross product. You know how to do that one, and after taking the cross product, you will take the dot product with the resultant vector. You can do that one for triple product. But what about this cross product? You can do two way. So this is B cross C. First you can write down the cross product, this B cross C. With respect to that one, you can take another, again say that if after taking the B cross C, you find out the new vector which is the D. Then you can take again the cross product A with the D. This is one way. Another way, we use a very short formula that we write actually B A dot C minus C into A dot B, that we define actually the back cap formula for cross product. Look at this. If I write down this letter side by side, BAC, or over here CAB, which actually that back cap formula. That's how you can find out easily the cross product of these three vector, or more than three actually we can find out the cross product in that way. But sometimes, say if the letter is different, I find out E cross G cross F. What I'm going to do over here, I need to do that performance, right? So there is another way actually. I do in another way this thing, but this one is very famous formula in the case in physics actually. We use that formula in the electrodynamics, because in that case we have to do a lot of cross product, more than 3 or 4 vector. We use this formula actually. It's called the backup. It's very famous in the physics student actually, backup formula, backup rule. But I use another way, because when this symbol is going to be the change, then it's not going to be the backup over here, right? Then what I did, I do another way actually. I label that letter by 1 2 3, then this one would be 2 1 3, and this would be 3 1 2. I remember this number actually. 1 2 3 would be 213 and minus 312. Then it is easier. I will write 2 is G over here, G dot E dot F, minus 3 is F, would be 1 2, which is E dot G. We can use in a short form, very short way, in that way. That should be the backup formula, or the vector triple product. And sometime you will find out, say I have the case, say that A cross B, I use the parenthesis over here. Now C. Now can I use my backup formula over here? Can I use the backup formula over here? You can't. You can't, because look at this. When you use the backup formula, they give you the parenthesis. That's when you have to take that operation first. You have to perform this operation over here, or you have to execute this operator, which is cross product, first inside this parenthesis. Then if I want to backup formula, then I'll do in my way. I'll write minus C cross A cross B. Right? I use that one, anti-symmetric properties A cross B actually minus B cross A. I use that idea over here. Then right now I can use my backup formula, but right now again I have to use in a form minus, it's a 2 1 3 first. I will use the parenthesis 2 1 actually A to C dot B minus B C dot A, right? And I will close this bracket over here. I can find it in that way. So if the case is say that more than 3, say I have a vector like that, A cross B cross C cross D, I have to find out this product. Then I can do, say I will consider this vector as a single vector, say there's the vector E with C cross D, right? Now I can use my vector formula over here. Again, it would be 2 1 3. 2 is actually C E dot D minus 3 1 2. 3 is D E dot C. That would be that actually that triple product, or is more than 3 or 4 vector, you can find out in that way. Alright, I'm sorry I take too much time. Thank you very much for your extra time. Don't worry, that is your investment. We will return the thing.
Assalamu alaikum, sir.
Alaikum
Thank you,
assalam.
sir.
Thank you very much.
Good day.
Assalamu alaikum, sir.
Alaikum assalam.
Thank you, sir.